Okay, scholars, so today we're going to continue talking about ionic bonding. So this is ionic bonding part 2. Okay. Ionic bonding part 2. And there are some things we need to know, some terms, definitions, and concepts that we need to have clear in our minds before we proceed. So, the first thing that we're going to think about is what makes up an ionic compound, okay? And an ionic compound consists of charged species. Now we said our definition was that a metal donates electrons to a nonmetal whenever an ionic bond forms. And all of our laptops should be awake. So, metal is donating electrons to a nonmetal. What that means is, as in our example from last time, we talked about sodium chloride, so sodium and chlorine. Sodium developed a positive charge, chlorine developed a negative charge. And so there are terms for those kinds of ions. So first off, ions are charged atoms. Okay? So ions are charged atoms. So sodium was an ion, and chlorine became an ion when they bonded together to make sodium chloride. And there are two kinds of ions. Someone needs to answer that. I'm not going to answer that phone. Or it can keep ringing. Okay, cations are positively charged. Nobody was there?
No.
That's fine. So cations are positively charged. So here's your example. Okay, sodium plus. All right, this is called sodium cation. So this guy right here is sodium cation. Now, how do we remember that cations have a positive charge? Well, take a look at this word cation. What do you see in the T that you also see right here? Yeah, you get that little plus sign, okay? That's an easy way to remember it. Another way is that we like cats. Humans like cats. Cats are our pets. We pet them. They purr. It's a good trade, okay? So, positive thing, cats. There we go. All right. Next up, anions. So anions are negatively charged. Okay? And again, cations and anions are both ions. Okay? They are the two types of ions. So our example for an anion is Cl-. This guy is called chloride. So this is chloride anion. Okay? And think anion like anti, negative. Okay? So anti, negative, that's what's going on there. Okay. So here are some terms, or some little pieces of information that we're going to want to have. All right? So, group 1 metals lose 1 electron and develop a +1 charge to become like, no one was there?
No.
Their nearest noble gas. Okay? That's what's happening. Similarly, group 2 metals lose 2 electrons and become 2+ charged. Okay? They get a charge of +2. Halogens this is group 17, okay? Gain 2 electrons, which means they become, sorry, not 2 electrons, 1 electron. They gain 1 electron, and they become just negatively charged like that, just 1 minus charge. And then group 16 nonmetals gain 2 electrons. They develop a 2 minus charge. Okay. So that's going to allow us to actually understand how these compounds are put together. So we're going to go with name here, and then formula here. So we'll start with the example we discussed last week, and that example was sodium chloride. Okay. So which group is sodium in?
Like the letter? S block.
It's in the S block, but which group? I'm pointing at a number. This is group
Group
1, okay? Also known as the alkali metals. So sodium is an alkali metal. And scholars, all of these guys over here in the S block, and the D block, and the F block, those are all metals, okay? We even have some metals over here in the lower left part of the P block, but you can easily remember that everything D, F, and S, metallic, okay? The vast majority of elements on the periodic table are in fact metals, all right? So these guys are all metals, these are all metals, these are all metals, okay? That's going to matter today because we're thinking about ionic bonding. And so what do metals do within ionic bonds? Do metals give electrons away or do they accept electrons? They give them away, right? So look at sodium. Sodium has 11 electrons, wants to become like neon, which has 10 electrons. So in order to participate in ionic bonding, it's going to give away 1 electron to become like neon. So if it gives away that electron, it's going to have 1 more proton than it does electrons. So it's going to develop a +1 charge. So sodium develops this charge, Na+, okay? +1, just like we said on the other side of the board. Chlorine needs to pick up a single electron to become like argon. So it develops a 1 minus charge, and we call that guy chloride. That is chloride. Now here's the thing about all ionic compounds. All ionic compounds are neutrally charged. So what does that mean? If you have a neutral charge, you have a charge of 0, okay? So take a look at this math here. Does this make sense? +1 plus -1 equals 0, right? So that's why we write the formula, the chemical formula for sodium chloride like this. NaCl, okay? 1 sodium and 1 chloride will balance each other in terms of charge, okay? That's a neutrally charged ionic compound, sodium chloride. Okay, that's fine, thank you. Okay, so sodium chloride, okay? And so, again, we can practice our skill of referring to these with our technical terms. This is called sodium. What kind of ion is it if it's positively charged? Cation. And if you're negatively charged, we have chloride, anion. Good, okay? So 1 sodium cation plus 1 chloride anion give us sodium chloride. Now, what's crazy about that is that this actually has a structure that's not just like one chloride and one sodium. It's actually a bit different. It builds, it's huge. We can see salt crystals, okay? So we're going to talk about that a little bit later on. Next up, we're going to discuss something else. So we just had a halogen with a group 1 metal. Now let's actually stay with chlorine, but we'll go with magnesium, okay? Now magnesium is a group 2 metal, group 2. So look, magnesium's got to lose 2 electrons to become like neon, okay? It's going to lose 2 electrons to become like neon. So what charge is it going to develop? Positive how many? 2, positive 2, okay? So magnesium, we've got magnesium chloride here. Okay? Magnesium has a 2 plus charge, but we already know that chloride's got to pick up how many electrons to become like argon? How many electrons will chlorine pick up to become like argon? 1 electron. So it develops this -1 charge. Now here's the trick, folks. We have to be able to understand how many of these we're going to need to balance this guy. This guy comes to the table with a 2 plus charge. So how many chlorides are going to have to be there to balance out the 2 positive for magnesium? 2. Okay, we got to have 2 chlorides. So we don't have a 1-to-1 ion-to-ion ratio. Instead, what we've got is magnesium and 2 chlorides. Okay, so that's a 1-to-2 ratio. No longer a 1-to-1 ratio, a 1-to-2 ratio. And later on, we're going to start calling this kind of ratio a molar ratio, but not yet. Not yet. Okay, now let's switch things up a little bit. Let's stick with magnesium, and now let's go with oxygen. Oxygen. So magnesium, this guy's called magnesium oxide. So oxygen's going to do what? Magnesium, we already said, was Mg how many plus? How many? 2 plus, right? It's going to lose 2 electrons to become like neon. And then oxygen's going to do what? To become like neon. Gain how many? 1, 2 electrons. Okay, so O, 2 minus. All right, 2 plus, 2 minus. Are these charges balanced? Is that correct, Erica? Are the charges balanced? How many positive here? How many negative here? That means balanced. When you have the same amount of positive charge as you do negative charge, you've got neutralized charge, balanced charge. Okay, that's very important. And so now we've got MgO. Okay? So within the context of our ionic compound, those charges are balanced. Okay? We do have a neutral compound, MgO. So that's magnesium oxide's formula. Okay, one more. So we're going to stick with oxygen, right? And we're going to look at a different metal ion, potassium. So we're going to try to write the formula for potassium oxide. Okay? And potassium is in the same family as which guy that we looked at earlier?
Group 1.
Which one?
Group 1.
It's in group 1. Good, right? What's the other atom that we saw from group 1 earlier?
Sodium.
Which one?
Sodium.
Sodium, right? Good. So what kind of charge do we think potassium is going to develop? -1? What's it going to do? What do group 1 metals do? They become positive how many, Angel?
1.
Positive 1, very good. Okay? So potassium is going to become potassium plus.